Today you'll learn how to build 3 Python AI projects that are designed for beginners. I'll be walking you through each step by step, and all you need is some basic Python experience to understand and complete them. Now these 3 projects are going to be the following. We have number 1, an AI agent, number 2, a resume critiquer, and number 3, an image classifier. To build these, you'll learn about LangGraph, LangChain, Streamlit, TensorFlow, OpenCV, and more. And by the end of the video, you'll have 3 great projects that you can adapt and build upon. Now, all of the code for these projects and the timestamps for them are down below. And with that said, let's go ahead and get started after a quick word from the sponsor of today's video, Recraft. Recraft is one of the most advanced design tools that I've ever used. It's a platform made for professional designers, marketers, and creative teams, and it just got a huge upgrade. Now, what makes Recraft different is that it gives you creative control. You're not locked into templates or left wrestling with prompts. You get tools that scale your design process. Now, the new Infinite Style library is honestly one of the coolest parts. You can explore thousands of curated styles, illustrations, icons, 3D art, and even photorealistic images and instantly apply them. Think of it like a design inspiration engine, but fully usable. Now you can save, reuse, and even mix these styles together, and the style mixing tool lets you blend reference images or style presets and actually adjust the influence of each one. It's like having Photoshop layers for aesthetics. Now this is a game changer for brand consistency. You can lock in your own custom style and then apply it across all of your assets no matter what you're making. And this isn't just about image generation. Recraft comes with a full toolkit: background remover, upscaler, mockup generator, infinite canvas, and live collaboration with your team. It's no surprise that it's trusted by designers at Netflix, Ogilvy, and HubSpot. Now, if you want to try it, hit the link below and use the code TIM11 to get $11 off any paid plan. Thanks to Recraft, and make sure to check them out. So I'm on the computer now, and I'm going to give you a quick demo of the 3 projects. Again, you can choose any one that you want to complete by looking at the timestamps down below, or you can do all of them. So the first one here is a simple AI agent. This is kind of just like a chatbot that has access to some tools. So we can say something like, hello world here, give this a second. Hello, how can I assist you today? I'm going to say, I need help with math, because this chatbot, for example, has some tools related to doing math operations. So I know this seems really basic, but I can do something like, can you, add 100 and 674, and then it should be able to give us the answer here, which is 774. I know this seems super basic, but we actually give this agent access to a calculator so it can go and do these math operations, which LLMs typically are actually very bad at doing. By doing this project, you're going to learn how to give agents access to various tools. So while this is simple, by building this out, you'll be able to build something much more complicated. Great, let's move on to the next one. So the next project here is an AI resume critiquer. Now this allows us to upload a resume using this nice kind of Streamlit user interface, which you see here, which obviously I'll show you how to build. We can then put in the type of role that this resume is for. So in this case, it's a software engineer resume. I just uploaded one here, and then we can press analyze. We can wait a second. It will actually read in the PDF, pass it to an LLM, and then it will give us some response. So let's wait for that here. Okay, so you can see here that we have a bunch of information, kind of analysis here on the resume saying, hey, this is what you could do better. Here's recommendations. Here's what I like. Here's what I don't like, etc. And there you go. Let's move on to the next one here, which is an AI image classifier. All right, so this one allows you to upload any image that you want. You can see I just uploaded this one of a dog, and then you can press on classify image, and it goes here and tells you the classification. So it says, 79% chance that it's a beagle, 12% chance it's this, I don't know this particular breed, etc. Now this doesn't just work for dogs, this actually works for any image. So you could use a car, you could use a cat, you can use a photo of you, whatever. As long as the model has seen something like this before, it should be able to give you a somewhat accurate classification, and we'll talk more about that when we get into that project. So anyways, those are the 3 projects. Now let's start building them out. All right, so let's go ahead and get started here. Now what I've done is I've opened up Visual Studio Code, and I've just opened a new folder. Now you can work in any code editor that you want, but first step, just open up some folder where we'll put all of the code for this project. Now what we're going to do here is we're going to use something called UV to install the various dependencies for our project. If you've ever worked with Python before, you may have heard of something called pip. Rather than using pip, we're using this new tool called UV. So I just want to make you aware of that because you do need to install this. So if you don't already have UV, you can simply install it from the link that I'll leave in the description. And if you're having any issues with UV, I'm going to leave a link to this this video here that I posted recently, which explains how to use UV, how to install stuff with UV, etc. Okay, so just make sure that you install UV. It's pretty simple. If you go to installation here, you can see that there's commands for Mac and for Windows. Run these commands, and then you should have access to the UV command, which we're going to use here in 1 second. Okay, so what we're going to do now is we're just going to make another folder inside of here. I'm going to call this project 1, and I'm going to go into the project 1 directory. So I'm going to say cd into project 1. So now I'm going to start typing my commands here while I kind of initialize the dependencies or install the dependencies for the first project, which is going to be our AI agent. So what I'm going to do is inside of this directory, I'm going to type the command uv init and then dot. This means initialize a new UV project inside of this particular directory, which is project 1 inside of here. So I'm going to go ahead and press enter. And then if you open this up here, you're going to see that you get a bunch of different files. We have getignore, Python version, myproject.toml, this README file. We don't need the README file, so we can go ahead and delete that one. And then we can write our Python code inside of here in this main.py file. Okay, so I'm going to clear out the main.py file, and now I'm going to install the dependencies that we need. Now, like I said, what we're going to be building here is a simple AI agent. In order to do that, we need the following. So we're going to type uv add and then langgraph, okay? Then we're going to bring in langchain. Then we're going to bring in python.env. And then we're going to bring in one more here, which is langchain-OpenAI. Okay, so we need these 4 packages, so go ahead and press enter, and then you should install all of them, and you'll notice when you use UV, this is very fast. So again, langgraph, langchain, python.env, and langchain OpenAI, and I'll talk about how we use all of these in just 1 minute. So now that we have those installed, we can start writing our code. However, we are going to need an OpenAI API key because what we're going to be using for these kind of AI projects is an LLM, right? Now, an LLM is something like GPT-4 or Claude 3.7 or Grok or DeepSeek. You can use any one that you want, but the simplest one to set up and the one that most of you are probably familiar with is the OpenAI API or like the GPT type LLMs. So that's the one that we're going to use here. Now, in order to use this LLM, we're going to have to use an API key, which we're going to get from the OpenAI website. So we're going to go into our project here, and we're going to make a new file called .env, which stands for environment variable. Inside of here, we're going to put our kind of secret key. So we're going to make a variable here, and we're going to call this OpenAI _ API _ key in all capitals. And you need to make sure that you type it exactly like this. Okay, so make the .env. Make the variable, and then here we're going to paste that API key, which I'm going to show you how to get. So to get the API key, we're going to go to platform. So let's go like this, .openai.com/API keys. Now, in order for this to work, you need to have an OpenAI account, and you do need to have some credit card on file. Now, this is just going to cost you like a cent or 2 cents. In fact, sometimes it's even free depending on how much you use it. So it's not like it's a very expensive thing, but in order to use the API, you do need to have an account. And again, I believe you need some credit card on file. So let me sign in here and I'll show you how to get the key. Okay, so once you're signed in and you go to this site, you should just be on this page where it says create a new secret key. So I'm going to make a new one. I'm just going to call this, AI project or something, put it in my default project and make the key. Obviously, you don't want to share this with anyone, so make sure you hide it. I will delete this one after the video. So what I'm going to do now is I'm going to paste this inside of here. Okay, so where it says, OpenAI API key, I'm going to paste in this variable. And now we will be able to use this from our main.py file. Okay, so from main.py, we're going to start writing some code now. So we're going to start here by saying from langchain _core .messages, and we're going to import this human message. Okay. We're then going to say from langchain _OpenAI, we're going to import the chat OpenAI tool. Okay, that's because we're going to use this to connect to OpenAI and kind of have our LLM running. We're going to say from langchain.tools, import tool in lowercase. All right, we're going to use this to register a tool that our AI agent can use. We're then going to say from langgraph.prebuilt, we're going to import a create react _agent like that. Okay, and I think that I spelled this correctly. It should be fine. Okay, then we're going to say from .env import load.env. Okay, so let me quickly explain these imports here. Now, LangChain is something that is kind of like a high-level framework that allows us to build AI applications. LangGraph is a little bit more of a complex framework that allows us to build AI agents, which I'm going to define in 1 second. And then the LangChain OpenAI obviously allows us to use OpenAI within kind of LangChain and LangGraph, which are kind of coupled together. Then we have this .env module, and this .env module allows us to load these environment variable files from within our Python script, so that's why we're bringing that in. Now, like I said, we're building an AI agent. The difference between just like a chatbot and an AI agent is that an AI agent has access to tools. So what I'm going to show you here how to do is how to make a simple Python tool that the agent can use so that it can go out and do something beyond just simply responding to your message. So in this case, we'll make a really simple tool, which is a calculator, but we could make any kind of tool that we want. A tool that saves a file to a node, a tool that calls an API, a tool that turns on or off your lights, like whatever you want to do, you can make a tool here. And that's the point of me showing you this project. So let's get into it now. So first thing we're going to do is we're going to call this load.env function. Now again, what this does is just looks in the current directory for this .env file, and then it loads in the variables so that we can use them later on in our program. Okay, next we're going to make a function. So we're going to say define main, and inside of here, we're going to initialize kind of our chatbot and our AI agent. So for our AI agent, we're going to have an LLM that kind of acts like the brain. Now in this case, we're using OpenAI. So we're going to say model is equal to chat OpenAI like that. And then we can pass the temperature of this equal to 0. Now, the higher temperature you go here, kind of the more random the model is going to be. When you go temperature 0, it just means that you don't really want any randomness at all. Okay, next we're going to say tools is equal to an empty list. And that's because in a second, we're going to be able to fill this with tools that our agent can use. And then we're going to create an agent. And to do that, we're going to say our agent executor is equal to a create, and then this is going to be the thing that we did, create React agent, and we're going to pass in our model and our tools. Now what we're doing here is we're using this create React agent from LangGraph, which is a pre-built agent that just takes some kind of model and some kind of tools and automatically handles kind of how to use these tools and how to utilize the model. So we're not getting too complex here. LangGraph allows us to build some really complex stuff, but we can just bring in this kind of pre-built agent framework. We can just plug into it a model, plug into it our tools, and then we can start using it. So that's literally all that we're doing here. Okay, now beneath this, I'm just going to copy in some print statements to save us a little bit of time. But you can see here that I'm just printing, welcome, I'm your AI assistant, type quit to exit. You can ask me to perform calculations or chat with me. Okay, now you can type anything that you want here. And if you want to copy anything that I write, you can find it from the link in the description. I'll leave like a little GitHub link that has all of the code for the project. All right, so after this, what we're going to do is we're going to set up a while loop. Now, the idea here is that we want to keep looping and allow the user to kind of interact with this like a chatbot so it can just keep asking questions and then our model or our agent, can keep responding. So first thing we're going to do is we're going to collect the user input. So we're going to say the user input is equal to input, and then we'll just say u : like this, and then we're going to say .strip. .strip is just going to remove any of the leading or trailing white spaces. So if you type something like this, then it will just give us this without the white space at the beginning or the white space at the end. Okay, that's all the .strip does. Now we're also just going to put a \n before the u just so that it goes down to the next line so that we have a little bit of separation between our user input and whatever the kind of agent is saying to us. Now what we're going to do is we're going to check the user input, and we're going to say if the user input is equal to quit, okay, because that's what we put right here, then we're going to exit out of the while loop. So to exit out, we can simply just type break. Okay, so if they type quit, then we will get out of this and we'll end the program. All right, otherwise, if they don't type quit, then we want to use our AI agent. So to do that, we're going to do a print statement. We're going to put a \n. We're going to say assistant : and then end is equal to an empty string. Now what I'm doing right here is I'm saying, okay, the assistant is about to start responding to us. We're going to end with nothing. Now, let me explain how this works. When you use a print statement in Python, by default, it's going to print this \n character at the end of whatever's printed. That's what makes the terminal go down to the next line. So what I'm doing is I'm overriding that in this print statement. I'm saying I don't want to do that. I don't want to put this at the end of the line so that when we start printing something else, we can print it kind of after this assistant, not on the next line. Hopefully that makes sense, but we're just making sure that we're not kind of putting this new line character so that we can print all of the stuff the assistant says kind of right after we say assistant. Okay, then we're going to say for chunk in the agent executor dot stream. Okay, bear with me here for 1 second. And we're going to put a dictionary. We're going to put messages, colon, and then we're going to say human message. And we're going to say the content is equal to the user input. Now, I know this seems a little bit weird, but essentially what's going on here is we're able to stream the response from our LLM using this agent executor, okay? So the agent executor is like our agent, right? If we want to actually use the agent, we need to kind of call it or give it some input. So we say, okay, we want to stream whatever the output is based on our input. So we say dot stream. And then the way that this works here is we need to pass in the messages to stream to our agent. So we say, okay, here are the messages. And then we just have one message that we want it to respond to. And this is a human message, right? Coming from us rather than something like a system message. And the human message says, hey, the content is this, okay, which is whatever the user typed in. So that's just how you kind of call this agent. All right, so now that we've called that, we're going to put a colon. And then inside of the for loop, we're going to do the following. So we're going to say if the agent is in chunk, okay, and messages is in the chunk agent, then we're going to move to the next line. Now, what I'm essentially saying here is, okay, I'm going to loop through all of the chunks. The chunks are essentially parts of a response coming from our agent. So we're looping through all of those. We're going to check to see, okay, is there an agent response, or like, is the current chunk that we're looking at, a response from the agent? If it is, we're going to check if there's any messages in that particular response. That's what this does right here. And then if there is, what we're going to do is we're going to loop through them. So we're going to say for message in chunk, and then we're going to say agent, and then messages like that. Then what we're going to do is we're going to print the message dot content, and we're going to say end is equal to an empty line. Now, why are we getting this? It's because I said from when I want to say for. That's the line that I meant to do. Okay, so essentially what we're doing is we're looking at all of the chunks that we're getting from our agent executor. We're making sure that it comes from the agent, okay? So if it comes from the agent and there's some messages, we're going to grab all of those messages, so loop through them, and we're going to print out all of the message content, and then we're going to end with this kind of empty string so that we don't go to the next line. What this is going to do is allow us to stream these longer responses from the agent. So it looks like the agent's kind of typing word by word rather than just printing the entire message at once. We can kind of stream the response. So like how you see kind of ChatGPT responding to you and you get it like typing word by word, that's what we'll see here as well. Now, after we do this, we're just going to put a print statement so that we'll kind of print an empty line. And then what we can do is we can say if underscore underscore name is equal to underscore underscore main underscore underscore, then call the main function. Okay, now you're probably wondering what the heck is this? This is just a simple convention in Python that you use whenever you want to execute kind of a main function. All it says is that we're only going to call this function right here if we execute this Python file directly, rather than if the Python file were to be, say, imported from some other file. Don't worry too much about it, but this is all you need. We say if this, then we're going to call this main function. This is the main function right here that we just wrote. In the main function, we initialize a model. Now, the reason why this model will work is because we've loaded in the environment variable, which is our OpenAI API key. This key needs to exist in the environment variable in order for this model to load correctly. Okay, so we load chat OpenAI. We then have our list of tools, which I haven't yet filled, but we'll do that in 1 second. We then create an agent executor with our model and our tools. We just print some basic messages, and then we go into this while loop where we essentially ask the user for some input. We then send that user input to the agent. We take the response from the agent, we kind of stream it out, and we print it to the console. So we're going to look at the tools in 1 second, but for now I want to run this script and make sure that it works. So in order to do that, we're going to open up our terminal. We're going to make sure we're in the correct directory. In this case, I'm in project 1. Okay, and then we're going to type uv run and then main.py. Now you need to do this. You need to use uv run because we've installed all the dependencies with uv. So when we do this, it will make sure that we're using the correct Python interpreter and that all of the dependencies are kind of initialized for this script. All right, so this is how uv works. Again, uv run main.py. We're going to go ahead and hit enter. We're going to wait 1 second here. And then it says, okay, welcome, I'm your assistant. You can type to us. I'm going to say, who created the world or something. And let's see what it says for that. And then wait 1 second, it says assistant, and you see that we get the response. So the concept of who created the world varies, blah, 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 blah. Okay, and then if we type quit, it should exit, and there you go. It sees, or you see that we exit. Okay, perfect. So that is that. This is working. Now, though, we want to add a tool that our agent can use. Now, a tool is just some external service that the agent can call to and, well, utilize. So in order to create a tool, it's actually quite simple. To do that, you do this at tool. Okay, this is called a decorator in Python. You then can define a function. So in this case, we can call this, calculator. We then take in some parameters. So I'm going to take in A and B. And for the parameters, you should define a type for them. So you can do this thing in Python called a type hint, where you put a colon and then you specify the type that you want the parameter to be. So in this case, it can be a float, but we could also do something like a string or an int or a Boolean, right? So we can specify whatever we want the type to be. And then we're going to do another type hint, which specifies what we're going to return. So I'm going to return a string from this. Okay, so we said we're taking in a float. We're taking in another float called B, and then we're going to return some string. And then you should specify what's known as a doc string. A doc string is essentially a description of the function, or in this case, a description of the tool, so that our LLM or our agent knows when to use this tool. So it's going to look at the name of the tool, which is the name of the function, the parameters and the return type, as well as this description. So for the description, I'm going to say this is a useful for performing basic arithmetic calculations with floats or with numbers. Okay, so we're just describing the tool so the agent knows when to use it. And then we can say return, and I'm just going to return an F string. I'm going to say the sum of A and B is, and then A plus B. Okay, so this is a really simple calculator, but all this is doing is just adding two numbers together and then returning a string saying, the sum of A and B is whatever the sum of A and B is. So this is one very simple tool. We can now use this tool by just putting the name of the function inside of this list. So we specify the tool, we put the name of the function here, and now we will have access to this tool. And if we want to see if it's working, let's just do a print statement here and say tool has, been called, so that we can see if the tool is being called by our agent. So now our agent has access to this. So if we go back here and we rerun our code, we should be able to use this. So I can say, can you add, 7 and 9? Okay, let's give this a second. It says tool has been called, and it says the sum of 7 and 9 is 16. So the agent will determine when to utilize the tool, if it needs to or not. So for example, if I say hello, it's not going to use the tool, right? Because there's no need to use it. But if I ask it for some arithmetic operation, then it will determine, we need to use this tool. It will go out and it will use it. Now, if you wanted to make another tool, you could just copy something like this. So you could say tool, and you could say, say hello or something. And we're going to take in maybe some name, and we're going to say useful for greeting a user. Okay. And then what we're going to do is say, tool has been called. And then rather than this, we'll just say, hello, name, I hope you are well today. Okay. Then we could put the tool right here. So we could say hello. And now our agent has access to two tools that it can use. Again, they're kind of useless, but I'm just showing you quick examples. So if I rerun this now, I can do something like, greet Tim. And then it says tool has been called, and it says I have greeted Tim. Okay, that's kind of weird. It should have given us the response, I guess. But either way, it did call the tool. I guess it just didn't really find this, response useful, so it didn't give it to us. The point is, though, that you can make all these tools, which are Python functions that can do literally anything that you want, pass them to the AI agent, and make some really cool applications. So that was the point of what I wanted to show you here. This is how you set up a basic AI agent. You give it access to a few different tools. You can kind of see if the tool's running or not. Now let's move on to the next project, which is going to be that resume critiquer. So we're moving on now to project number 2, which is the resume critiquer. Now for this project, we're actually going to make a user interface. The user interface is going to be made with something called Streamlit. Now, Streamlit is a really easy library to use for making kind of basic web applications with Python. I'll walk you through it step by step, but you'll see here that it's very simple to utilize and is great for working with AI type applications. Now, what I've done is I've made a new folder here called project 2. So let's get into that folder. So I'm going to cd ... and cd into project 2 from my terminal. From here again, I'm going to type uv init and then dot to make a new UV project. So let's go ahead and do that. And then we're going to install the dependencies that we need. Now, the dependencies we need for this one are going to be Streamlit. Okay, so let's install that. We're going to need OpenAI because we're going to use OpenAI again for kind of an LLM for analyzing the resume. We're going to install PyPDF2. This is for loading our PDFs. And then we're going to have python.env. Okay, so we're going to go ahead and press enter. It's going to install all of the stuff that we need. And now we're good to go. All right, so let's go into project 2 here. And actually, I'm just going to start by copying my environment variable file from the last project and pasting it in here. Now, if you didn't complete the last project, what you need to do in order for us to work with OpenAI and to have this kind of LLM working is you need to create this variable inside of a .env file called OpenAI API Key. Okay, so that's what we've done right here. You then need to paste your OpenAI API key inside of this file as the variable so that we can utilize this and use this OpenAI LLM or like this ChatGPT LLM. All right, now in order to get the API key, again, what you're going to do is go to platform.openai.com/API keys. I will leave the link below. You will need to have an account and I believe a credit card on file in order to do this, but it is very inexpensive, if not just completely free. It might cost you like 1 cent or something to use this. So don't worry about the cost. It's more so you just need to have the credit card on file to be able to use this. Okay, so now we have the environment variable file. We're going to open up our main.py file. We're going to clear this out and we're going to start writing some code. Now, like I said, we're going to use Streamlit for the user interface. So bear with me if there's some things you haven't seen before, and I'll show you how Streamlit works. I also have an entire Streamlit tutorial series, or tutorial, I guess, which I'll put on screen now and you can check out. All right, so I'm going to say import Streamlit as st. I'm going to say import PyPDF and then 2. Again, we're going to use this in a sec for loading in our PDF files or our resumes. We're going to say import IO. We're going to say import OS. We're going to say from OpenAI, import OpenAI. And then we're going to say from .env, import load.env. Okay, now first thing we're going to do is call this load.env function. What this is going to do is load the environment variable from our .env file so that we can utilize it from within this Python script. Now I'm going to start typing a few things related to Streamlit. I'm going to show you how we run the Streamlit application, and then all of this will make sense. Okay, so first things first, we're going to say st. This is Streamlit, right? And we're going to say .set _ page _ config. Okay, now this allows us to configure kind of the name of our tab or of our page like you would in HTML, for example. So we can say the page title is equal to, and then we can say AI resume and then, critiquer or whatever we want to call it. So this will be like the name of our website effectively. That's what we're setting. Then we can do something like set the page icon. So we can say page icon is equal to, this is like the fave icon or the fav icon. And we can put in an emoji. So I'm going to go with something like page. Okay, so I'll put that in here. And then we can say the layout is equal to, and for our layout here, we're just going to go with centered, which means we're going to put everything in the center of the screen. You don't need to put this line here, but it just kind of configures a few things to make the page look a little bit nicer. Now, the way that Streamlit works is that we can effectively write anything that we want onto this page, and Streamlit will automatically handle rendering it correctly. So we can write a graph, a data frame, some text, a title, some markdown, pretty much anything that we want, and Streamlit will just automatically handle writing it, or we can tell Streamlit the way we want it to be written. So what I'm going to do is I'm going to say st.title, and all this means is we're just going to write a title onto the screen, okay? So for the title, I'm just going to say this is AI resume critiquer, like that, okay? Then beneath that, I'm going to say st.markdown. And here, I'm just going to put some text. I'm just going to copy it in to save us a little bit of time to kind of tell the user what they need to do. So I'm going to say upload your resume and get AI-powered feedback tailored to your needs. Okay, so I'm saying I want to write some title text, which is this, and I want to write some markdown text, which is just this text right here. That's it. Okay, so I want to show you how we run this before we go any further so you can kind of see what it looks like and how the writing kind of works with Streamlit. So when we have this Streamlit application in Python, the way that we run it is the following. We need to run the command, which is Streamlit run, and then the name of our file, which in this case is main.py. When we do this, it's going to use Streamlit to load in this Python file and like kind of render the user interface for us in our web browser. But because we're using UV, we need to use the command UV run and then Streamlit run main.py. So whenever you're using UV, you always run the command UV run. And then what we want to do is, well, we want to run the Streamlit command. So we're going to say Streamlit run main.py. So it's UV running the Streamlit command, which is running our Python file. Hopefully that makes sense, but because we're using UV, that's kind of how we get this going. So we're going to go ahead and press enter. When we do that, you're going to see that it should open up a web browser, and you should just get the text that you wrote. You can see here, it shows you, where your Streamlit app is running. In this case, it's on localhost port 8501. If it didn't open that up, you could just copy this into your web browser, and you can see here that our Streamlit application is now running. Now, anytime anything changes in our application here, so whether state changes or whether we refresh the page, this entire Python file will be reran. It's kind of a weird way of thinking about application development, but that's just the way that Streamlit works. So if I come here and I do something like st.text and then hello or something, and I come back here and I refresh, you're going to see that now hello appears on the screen. Okay, so again, anytime we refresh the page or like any state changes, the whole Python script will be reran, and then it will just update whatever's on our website. All right, so let's close that for now, and let's start writing some more code, and you'll learn kind of more about how Streamlit works, but don't worry too much about the details. This is a pretty simple UI that we're making. All right, so next what we're gonna do is we're gonna load in our OpenAI API key. So I'm gonna say OpenAI _API _key is equal to os.getEnv, and then we're going to put the name, which is OpenAI _API _key. Okay, so we've just loaded that in. Now, the reason why we're doing that is we're going to pass this to this OpenAI module in just 1 second to kind of initialize our LLM. This works a little bit different than the AI agent we were using previously because this isn't an AI agent. We're just using the LLM to kind of analyze a resume. All right, so now that we've loaded in this key, we're also going to create some elements on the screen for doing things like loading our resume. So we're going to say our uploaded _file is equal to st.fileUploader. Okay, and here we're going to put some text. So we're going to say upload your resume, and then we'll just say that this can be in PDF or TXT format. Then we can specify the type that we want to be allowed. So we're going to say type is PDF or TXT. So the way that this works, whenever you have an input in Streamlit, is you could just write the input field that you want. In this case, it's a file uploader, and then you can have some variable which will store whatever that input is. So if we go back to our site here and we refresh, you can see now that we have this kind of file uploader. If we press on browse files and then we were to select one, that file would kind of get stored inside of this variable called uploaded file, and then we'd be able to access it later on. So it's very, very simple. That's why I like using Streamlit. Now beneath this, we're going to say the job role is equal to st.text input. Okay, so rather than file, we're just getting some text. And we're going to say enter the role or the job role you are targeting. Okay, and then we'll just say that this is optional. So this way they can just specify, hey, I'm going for a software engineer, I'm going for a mechanical engineer, whatever it is, so that we can have some better context for our LLM when it's giving responses. All right, so now what we want to do is we want to make sure that the user has kind of uploaded this file before we allow them to start analyzing their resume. So I'm going to make a button here, and I'm going to call this analyze, and this is going to be st.button. Okay, and we're going to say this is analyze resume. Now the way that the kind of buttons work here is that when you press the button, this variable will change to true. So then we can check if this variable is true, which will tell us if the button was pressed. So if I do something like if analyze, then as soon as the button is pressed, this will become true, this will run, and then we could do something like st.write button pressed. Let me kind of show you how this works so it makes sense. So if I go here and I refresh, you see that we have this button. If I press the button, it says button pressed. Okay, so essentially what ends up happening here is anytime any of these inputs kind of get a new value, the entire Python script is reran from the very beginning, but these values are stored in the state of the page, okay? So as soon as I upload a file, this whole Python script gets reran from the very beginning, but the file that I uploaded gets stored in this variable. Same thing with job role. As soon as I enter anything, the entire Python script gets reran, but the job role gets updated in the next rerun to store whatever it was I typed in here. When I press the button, same thing, the entire script gets reran, but the state of the button now, this variable, becomes equal to true. So now when I check this if statement, it prints out button pressed. Because if you think about it, right, when I first run this script, well, analyze is going to be equal to false because I haven't yet pressed the button. So then when I press the button, we need to rerun the whole script again. So then when I check if analyze, it will then be true, and then I can go to this next part of the script. So again, it's a very kind of weird way of doing things if you haven't seen this before, but effectively, again, you rerun the script every time, and then the state kind of gets stored in these variables, and you can check like, is this button pressed? If it is, then you can do something. So what we're gonna do is we're gonna say if analyze and uploaded file. Now this just means that we're going to have some content in the uploaded file, right? So this is not none, like there's something here. Then what we're going to do is we're going to try to load in our file content. So we're going to have a try, and we're going to say our file content is equal to, and we're going to load this in. Now in order to load this in, we're going to need a function. So I'm going to make a function here, and I'm going to call this extract text from file, okay? And this is going to take in the uploaded file. Now, the idea is here that our LLM can't actually accept a file, or at least the way that we're passing it to it, it can't take the file. So we want to take all of the text out of our PDF, kind of read it, and then pass it to our LLM. So we're going to say if the uploaded file dot type is equal to application/PDF. So we're going to need two equal signs here, sorry, to check if it is equal to. Then what we're going to do is we're going to return, and we're going to call another function, which is going to extract the text from our PDF. So we're going to say define extract underscore text underscore from underscore PDF. We're going to take in the PDF file, and what we're going to do here is say our PDF reader is equal to pypdf2 dot PDF reader, and we're going to take in the PDF file. We're then going to say text is equal to an empty string, and we're going to say for page in the PDF reader dot pages. We're going to say text plus equal to the page dot extract underscore text plus the \n character, and then we're going to return text. Okay, so how does this work? Essentially, we have this function. We take in some PDF file, which we'll pass here in 1 second. We then say, okay, we're going to load in this PDF file using this PyPDF module that we installed. Don't ask me how this works. We're just using the module. It's able to load in the PDF file for us. We then just make this empty text string. We're going to now add all the text from the pages. So we say for page in PDF reader dot pages. So loop through all of the pages, grab all of the text that's on those pages, and just add it to this text variable. We then return text. Okay, so now from this extract text from file function, we're going to put the extract text from PDF, if this is a PDF, and we're going to say io.bytes io, okay, and then uploaded file.read. All right, I know this seems a bit weird. Essentially what we're doing is we're taking this uploaded file, which is PDF file, we're reading it in, we're converting the read information, or the read information, sorry, into this byte object, which is then going to be able to be loaded by this PDF reader. And then we're extracting all the text from it, and we'll use that here. Okay, then we're going to go here, and we're going to say return uploaded file dot read, okay, dot decode, and then UTF-8. So what we're doing is we're checking, all right, is this a PDF? If it's not a PDF, then it must be a text file. So we can just read it and decode it as UTF-8. UTF-8 is the standard text encoding. And then now when we use this function from here, so extract text from file, we will get the text from our uploaded file, whether it is a text file or a PDF file. So if it's PDF, we go here and we use our PDF reader. If it's text file, we can just directly read it in. And now we have the file content. Okay, now we need to make sure that there is actually some content in the file. So we're going to say if not file content dot strip So remove, again, all the leading and trailing white spaces. So it has like any empty characters, we'll remove that. And we're going to do st.error. And we're going to say, file does not have any content. Okay, ... And then we're going to say st.stop. All right, now what this is going to do is essentially, if there's no content inside of the file, we're going to show an error message to our user, and we're just going to stop the program right here. Okay, now if this is not the case, right, so if we don't stop the program, then what we want to do is we want to create a prompt that contains the text from our PDF file. We want to pass this to an LLM, right, to this AI model, and we want it to give us some kind of critiques or recommendations for our resume. So let me just copy in this prompt here, and then I'll explain to you how it works. Okay, so this is our prompt. So we say prompt is equal to please analyze this resume and provide constructive feedback. Focus on the following aspects: content, skills, experience, specific improvements. And then we put inside of here job role if the job role does exist. Otherwise, we say general job applications. Okay, we then say the resume content is our file content, and please provide your analysis in a clear, structured format, etc. We're using an f string here, which allows us to embed variables inside of the string. You do that using these braces. You can use any kind of prompt that you want here. You can copy this one directly from the code link in the description, or you can just write your own. Okay, I'm just showing you a basic prompt. I just figured there's not a lot of value, in me typing this out line by line. Okay, now that we have that, we're going to say client is equal to OpenAI, and we're going to say the API key is equal to the OpenAI API key. So we're creating a client here so we can access the OpenAI LLMs, okay? And then what we can do is we can say response is equal to client.chat.completions.create. Now again, this is different than the AI agent we used previously because the AI agent had access to tools, so it was a little bit more complex. Here we can just directly invoke the LLM, so we can just use this OpenAI module. Okay, so we need to specify the model that we want to use here when we generate this response. So I'm going to go with GPT-4o and then mini, but you can use any model name that you want that's available. We're then going to say messages are equal to, and we're going to put a list. Now inside of here, we're going to have two messages. The first is going to be a role of system. A system message is something that it's not going to be directly replying to, but it kind of gives context to the model. So for the system message, I'm just going to tell it the following. Okay, so I'm going to have content, and I'm going to paste this in. And I'm going to say you are an expert resume reviewer with years of experience in HR and recruitment. Okay, so it kind of knows what it's meant to be doing and how it should be responding. I'm then going to have another message, and I'm going to say role, and this time it's going to be user, and the content is simply going to be the prompt. Okay, so we tell it, hey, act like a resume reviewer, and then we give it this message right here that we created, which is our prompt that contains the file content and the job role the user is applying for, if they have the job role. Then we can specify a few things here. So we can say like temperature is equal to 0.7, and we can say the max tokens is equal to like 1,000, for example, so that it never ends up costing us too much money. All right, so this is going to generate a response from us from the OpenAI LLM, or from GPT-4o mini or whatever LLM that we use, and then we need to print out this response. So beneath this, we're going to say st.markdown, and we're going to do kind of 3 pound signs here, so it'll be like a title 3, and we're going to say the analysis results like this, and then we're going to say st.markdown, and we're going to say response dot choices 0 dot message dot content. All right, the reason why we're doing this is because you can potentially get multiple messages coming back from this. In this case, we know we're just going to get one message, so we say response dot choices. That's kind of where it's stored. We get the first response. We then get the message from that, and we get the content, and then we render this as markdown because we'll get a markdown response from the LLM. So it will be able to show us kind of all of the nice formatting, the lines, the bold, the highlight, etc. All right, now last thing we need to do, you might remember that up here we had this try statement because there could be an issue with what happens here. So then down here, we're going to make an except, and we're just going to say except exception as E, And then if there is an exception, we're going to say st.error, and we're going to put an f string and say an error occurred. And then we're just going to show what the error is, which will be the string of E. Okay, that's it. We're just doing this to make sure, hey, if there's an error, we'll tell the user what it is and we won't crash the program. So let me zoom out a bit. Let's go over what we just did, and then we will run the code and make sure that it works. All right, so we start with all of our imports here. We load in our environment variable file. We set some configuration for the page, so like kind of the title of the page. We set the title and the markdown, or we just write that onto the page at least. So we say, hey, this is the title. This is some basic text the user should know. We then load in our OpenAI API key. We have two fields or two inputs here. So the file uploader and the text input. We have a button. We have two functions just for kind of loading the text from the PDF or from a text file. We then are saying, okay, if the button was pressed and you did upload a file, then what we're going to do is try to get all of the content from that file. If the file doesn't have any content, we show an error message. If it does, then we have this prompt, which just tells the LLM what we want it to do. We pass it our file content. We then create an OpenAI client so we can interact with our LLM. We generate a response from the LLM by specifying the model and our messages, and then we just print out what that response is. Okay, so let's go back here. Let's make sure this is still running. I believe that it is. We can go here. We can refresh. Okay, we should get our updated user interface. Let's grab a resume now. Okay, so here's one actually from one of the students in my mentorship program. By the way, if you guys are interested in potentially joining that, I have a waitlist open right now. I'll leave a link to it in the description, where if you want guidance directly from me and expert software engineers, you can join the Dev Launch Mentorship Program. Again, sign up for the waitlist below. Now, this person specifically is targeting web development roles. So let's analyze their resume by pressing the button and see what it tells us. Okay, so we get the results here and we can scroll through this. Now, because this is for one of my current students, I don't want to show all of the content just in the name of privacy. But the point is, it kind of gives us all of this. We can see the analysis, and then we could run this as many times as we want for as many resumes as we want. And I think this is a pretty interesting AI project. So there you go, guys. That wraps up project number 2. Of course, you could make this better, you could improve it, you could change it however you want, but hopefully this showed you how to use Streamlit and how to interact with an LLM. Now let's move on to the final project, which is our image classifier. All right, so now we're moving on to project number 3, which is our image classifier. Now, in order to do this project, again, I'm going to create a new folder, which I've done here, project 3. I'm going to cd into that project 3 directory, and I'm going to start setting it up with UV. Again, if you're unfamiliar with UV, go back to that first project, watch the beginning. I explain what UV is and kind of how to use it and some other resources in case this video isn't getting you there. Anyways, what we're going to do is we're going to type UV init dot. Okay, that's going to initialize UV inside of the project 3 folder. We're then going to say UV add, and we're going to add the dependencies for this project. Now, like before, we're going to use Streamlit, we're going to use TensorFlow, and we're going to use OpenCV Python. Okay, now don't worry if you're unfamiliar with OpenCV or TensorFlow. TensorFlow is going to allow us to bring in a pre-trained machine learning model that can look at an image and classify it. And OpenCV is going to allow us to do some manipulations on the image that we load so that we can pass it to TensorFlow. Okay, so we're going to install all of those dependencies. It might take a second because these are fairly large. And there we go, they have been installed. Okay, so now we're going to go to project 3. We're going to open up main.py, We're going to clear that out, and we're going to start writing some code. So as always, let's start with our imports. So we're going to say import CV2, which is OpenCV effectively. We're going to say import NumPy as NP. NumPy is installed by default when you install TensorFlow, so we have it. We're going to import Streamlit as ST. We're going to say from TensorFlow. Okay, and this one is going to be a little bit long. .keras, .applications, .mobilenet underscore v2, import, and then we're going to import a few things, and I'm going to put these in parentheses. We're going to import mobilenet v2. We're going to import the pre-process underscore input and the decode underscore predictions. Okay. Then we're going to say from PIL, import image, which is an image library in Python. Again, that is installed with CV2 by default. Okay, so let me explain what's kind of about to happen here, because there's a lot of stuff that we're using. Now, TensorFlow, and Keras specifically, contains a lot of pre-trained machine learning models. Now, typically a machine learning model needs to be trained, right? You need to pass it a bunch of data. It needs to learn kind of the information about, what makes a dog, what makes a cat, etc. In this case, we're not going to train a machine learning model from scratch. We're just going to use a model that already exists. Now, a popular model that comes from TensorFlow is called MobileNet V2. This is a very lightweight model, which means you can run it even on something like a laptop, as opposed to like something that has a big GPU or something. And again, it's just called MobileNet V2. So that's the model that we're going to use. It's already trained. We can just download it to our computer, which will happen the first time that we run it. And then we can simply pass it images in the correct format, and it can then classify those images for us. Now, obviously, if you wanted a more advanced project, you could train the machine learning model yourself, but I don't want to do that in this video because that's going to take a very long time and get into some much more complex stuff that's not meant for a beginner tutorial. So this is going to show you essentially how you use this pre-trained model, and then how we can present it with Streamlit, for example, and how we can do some basic image manipulation. So we're going to write a function here called load model. Now, all this is going to do is load in this MobileNet model for us. So we're going to say the model is equal to the MobileNet V2. And then we need to specify the weights that we want to use for this model, which is going to be the ImageNet weights. Now, again, you don't need to worry too much about what's going on here because we're using a pre-trained model, and we're just going to return the model here. Now, what I will say is MobileNet V2 is what's known as a convolutional neural network. This means that it employs a specific technique and architecture to essentially be able to look at images, okay? Now, for this particular architecture, you have these weights, okay? These weights are like the learned values that essentially make the model work how it works. So when this model was trained previously, all of these weights, which are essentially these unique numbers, were determined to, equal some particular output. So we're just loading in those weights. There's different weights that you can choose from. And when we load those weights with this particular architecture, we get this pre-trained model, which is generally good at classifying a lot of different types of images. I'm trying to be kind of vague here because this could be a whole video on its own explaining how MobileNet V2 works. But the point is, this is already trained. We bring in some particular weights for it, and then we can just use it. Okay. Now, next thing we're going to do is we're going to write a function called pre-process, and then this is going to be image. Let's spell process correctly. Now, this is going to take in some image, which we're going to load in 1 second, and we're going to use OpenCV as well as NumPy to essentially turn this image into something that MobileNet V2 can understand. So all of these machine learning models, typically they have some kind of input structure. Maybe the input's a string, maybe it's a number. In our case, it's an image. But we can't just pass any image. The image needs to be the correct color, it needs to be the correct size. So we're going to take any image that we upload, and we're going to convert it into the correct format so that we can pass it to MobileNet V2. So what we're going to do is we're going to say our image is equal to np.array. Okay, so numpy.array, and then image. This takes this image and it converts it into an array of a bunch of different numbers. So images can be represented as arrays, okay? Essentially, you have arrays where you have these rows and columns, or these lists, right? So we have different rows and columns, and every single value, so if we had like 0, 1, 2, whatever, represents a value of a particular pixel in our image. So if we had an image that was, I'm just doing something really basic here, right? Like 3 by 3 pixels by 3 pixels, this is what the array representation might look like, where we have, again, kind of rows and columns, and every single value is the color of a particular pixel. Now, obviously, it's a little bit more complicated than that, but what we're doing is we're taking the image and converting it into an array because that's the format that this will expect. Okay, so now after we do that, we're just going to resize the image. So we're going to say image is equal to cv2.resize the image, and then we're going to go 224, 224. Okay, so we need to have our image in a size of 224 by 224. So we're just going to resize it to that size, and we'll let OpenCV take care of automatically resizing it there, adjusting it. And yes, this does mean we're going to lose some detail in our image. So a really big image might not work really well here, but that's just the size that MobileNet V2 accepts. So that's what we need to convert it to. Okay, so now after that, we're going to say image is equal to pre-process input, and we're going to pass in our image. And then we're going to say image is equal to np.expand underscore dimensions or dims, and we're going to pass image, and then axis is equal to 0, which I will explain here in 1 second. Okay, so what this line is doing is it's just taking our single image and it's converting it into a format that would represent multiple images, because typically these models, they accept like a batch of images, so 10 images, 20 images, 30 images at a time. In our case, because we only have one, we need to convert it into a format where it looks like it's a list of images or multiple images. So this adds another dimension to our image essentially to make it look like it's multiple images. Even though it is just one image, it's effectively like wrapping our image in a list, okay? That's kind of what we're doing. I know this is weird. That's what's going on, okay? And let me just quickly, again, recap what we did. So we converted the image into an array of numbers. We resized the image to 224 by 224. We pre-processed the input. This is a function that comes directly from MobileNet v2, where it just takes this and pre-processes it so it's ready to actually be sent to MobileNet v2. Again, you don't need to worry about exactly what's happening here. And then we take that individual image and we convert it effectively into like a list of images that we're going to be passing now to our model. So from here, I'm just going to return the image. Okay, and now let's go to our next function. So the next function is going to be classify underscore image. Okay, we're going to take in the model and the image that we want to classify. Now we're going to have a try and accept block, and we're going to say inside of try, the process underscore image is equal to pre-process image, the function that we just wrote. We're going to pass in our image. We're then going to say the predictions are equal to model.predict, okay? And we're going to predict based on the processed image. We're then going to say the decoded underscore predictions is equal to decode predictions. And we're going to pass in the predictions. We're going to say top is equal to 3, and then we're going to take index 0. Okay, now let me explain what's happening here. Essentially, this decode predictions function, what it will do is it will take the numeric predictions that are being generated by our MobileNet v2, and it will convert them into string labels so that we're able to actually see what the predictions are. And in this case, we're just saying that we want to take the top 3 predictions. Now we grab the 0th index here because, again, the model is expecting multiple images, but because we're just passing one image, we know we're just going to have one response. So we grab just the only response the model gives us, right? And then we can kind of get the decoded version of that. Now let me explain what I mean by this. Essentially, the way this model works is we pass to it some image, right? So we pass it some image, and then it gives us this array that looks something like this. It's going to be like 0.9, 0.1, 0.02, 0.0. It's going to give us like all of these different values. Now, all of these values represent a percent confidence or like a classification percentage, and these indexes within this list correspond to some label. So like index 0, for example, corresponds to a dog. So if we had 0.9 here, this means there's a 90% chance that this image is a dog. Then index 1 here might represent a cat or a house or some other object, some other classification, okay? So we have all these values, but what we need to do is we need to decode these values so that rather than just having all of these random percentages, we actually know what label they're associated with. So what decode predictions does is it takes all of these numbers, right? These like percentages for the classification, and rather than just giving us these, it gives us the text label associated with them. And then when we have top 3, that just means we grab the top 3 predictions, so the ones with the highest percentages, and we grab those and show them rather than showing every single prediction. Okay, so that's what's happening with this decoded predictions function. We decode the predictions that we got from the model, and then we grab just the first response with the top 3, and then we can print those out. So from here, we're going to return the decoded predictions. Okay, we're then going to say accept exception as E, and then we're going to say st.error, and we're just going to put an f string, and we're going to say, error classifying image. Okay, and we'll put the string, what am I doing here? The string of E inside a set of braces. Okay. So we said error classifying image, and then we just take whatever the exception is and we print it out, and then we can return from here none. Okay, cool. So now we have our classify image function. Again, let me just make this look a little bit cleaner. What we're doing is we're pre-processing the image. We're passing it to the model, so we can just use model.predict to do that. And then we get the decoded predictions, and let me fix the spelling mistake here. We then return them so we can print them out in our Streamlit UI. So now we can actually start using the model. However, I want to wrap this in like a user interface so that it kind of looks nice. We can upload the image, etc. So let's make this main function here. And this is where we'll put our Streamlit UI. So we're going to start by saying st.set_page_config. From here, we can have the page title, and this can be the AI image classifier. We then can have the page icon equal to, I'm on Windows, so I can bring in an emoji by hitting the Windows sign and the period. Let's go with like, I don't know, picture or something. Okay, so we can put a picture frame, and then the layout will be equal to centered, so that everything will be in the center of the screen, or in the center of the screen, sorry. Then I'm going to say st.title, and I'm going to say AI image classifier on screen, and I'm going to say st.write, and I'm going to write upload an image and let AI tell you what is in it. Okay, so that's our image classifier. Now what we're going to do is I'm going to say at st.cache_resource. You'll see why we need this in 1 second. I'll explain what it does. I'm going to say define load cached, okay, model. And then this is going to return the load model. All right, so in Streamlit, you can cache resources that you're going to use quite frequently. If you watched the previous project, you know that the way that Streamlit works is that anytime any state changes, the whole Python script is reran. So if I were to just keep calling this load model function, I would keep doing this, like loading MobileNet v2, which can take a second to load. So rather than continually loading the model over and over and over again, we're going to cache this. So we can say, all right, I want to cache this resource. So now when I call this particular function, if the model has already been loaded, it will just return to us that loaded model. It won't load it again. Okay, so this is just a very simple cache that we're building here. Again, it means we're not going to keep loading the model over and over again. We're just going to use the same model that was already loaded in a previous run of this Streamlit app. Okay, so then down here, we're going to say model is equal to load cached model. So now we're using this cache to access the model, so we don't repetitively do that. And then we're going to put a file upload. So we're going to say uploaded file is equal to st.fileUploader. And inside here, we're going to say choose an image, ... And we're going to say the type of the image can be a JPEG or a PNG. Okay. Now we're going to check if a image was actually uploaded. So we're going to say if uploaded file, and we'll actually just say if uploaded file is not none. Then what we're going to do is say our image is equal to st.image. And we're just going to show the uploaded file on screen. So I'm going to say uploaded file, and then we can add a caption for this. And I can say this is uploaded image. And we're going to pass this thing called use container width is equal to true. Okay, so what I'm doing is I'm just displaying this image on screen. So I'm saying, hey, let's show the image. So we have the uploaded file. That's what we're showing as the image. Here's the caption. And we're just going to use the container width, which means we're going to use the whole width of the screen. All right, so then I'm going to put a button. So I'm going to say btn is equal to st.button, and I'm going to say classify image. Okay, I'm going to say if the button, so if the button was pressed, then what we're going to do is say with st.spinner. This just means we're going to show this kind of loading icon. We're going to say analyzing image like that, ... Then we're going to say image is equal to image.open, and we're going to open the uploaded file. Now, image here is coming from pill. This is a utility that allows us to work with images in Python. Okay, so we're opening this image, and then we're going to say the predictions, okay, are equal to the classify image, and we're going to pass in this image. Okay, then we're going to go down here, and we're going to say if predictions, we're going to say st.subheader, and we're going to say predictions, and then we're going to loop through the predictions and show them. So we're going to say for underscore, comma, label, comma, score in the predictions. Then we're going to say st.write, and we're going to write like this. We're going to do asterisk, asterisk, label, asterisk, asterisk to make this bold. Then we're going to say score, colon, dot 2, and then this is going to be percent. Now what this is going to do is it is going to take 2 decimal places, and it's going to show this as a percentage rather than as like a decimal value. And so we're going to have the label in bold, and then the percentage that we think this is, like the percentage accuracy or the percentage confidence we have that this label is this image, or this image is this label. Now, the reason why we're doing this in the for loop is because our predictions are going to contain 3 values. We're going to have the index, something like 0. We're going to have the label, so maybe like car, and then we're going to have the score, something like, 0.9. So we don't care about the first one, so we can just use an underscore, which is known as an anonymous variable in Python. We also could just put IDX or something, but we just wouldn't use that variable, so we just put an underscore instead. And then we can use the label and we can use the score here. Okay, so that's that. Last thing we need to do is we need to call this function. So we're going to say if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, then we're going to call the main function. Okay, and we'll just add a space here. Now, in case you didn't see this in the other project, all this means is that if we run this Python file directly, we will call the main function. If we're not running the file directly, or we're importing it, for example, then we won't run this. All right, so I do want to run the Streamlit application now. So to run the application, we're going to make sure we're in the correct folder. So we're going to go to project 3. We're then going to type uv run Streamlit run and then main.py. The reason why we're doing this is because we're using UV for our dependencies. If we want to run a command with UV, we do UV run, and then the command we want to run is Streamlit run main.py, which will run our application as a Streamlit app. So let's go ahead and press enter here, and it should load this up for us. Just give this a second. Also, we may potentially have an error or it's loading something. So it looks like it's loading something from TensorFlow, so let's wait for that to finish. Okay, seems like we're good. And then here you can see it says, choose an image. So let's browse for a file and find an image. We can open up this dog image that I had before. So you see, we have this, and then we can press on classify image. Okay, and we got an issue here. It says classify image missing 1 required positional argument image. So let's go back here and let's figure out the issue. So for classify image, we need to pass the model. So let's pass the model and the image, okay? I forgot to pass the model, so that's why we're getting that error. So let's fix that up. Let's save, let's refresh, and let's do this again. Browse files, find the image, okay, a nice dog, classify image, and then you see we get the classifications here. Now you can mess around with this for various different images. Again, it's not always going to work perfectly, depends on the type of image that you have. The more common the item, the more likely it's going to work. So let's look up no, that's not what I want. Let's look up like car or something. So let's go here. Okay, let's grab one of these here. Let's go save image as, and there we go. It's a JPEG. Okay, let's change the image. So browse files. Let's grab our Bugatti. Let's go classify image, and you can see that it says sports car and convertible. Okay, that's interesting. I don't think this is a convertible, but that's a pretty good classification, I would say, for this type of image. So there you go, guys. That is going to wrap up this project. That is how you make an image classifier in Python. I know this is fairly simple, but I wanted to show you 3 beginner AI projects that you can finish in not too long and that are kind of fun to mess around with, that you could extend and make into your own. Let me know what you guys think of this project or these projects in the comments down below. A reminder, all of the code will be available from the link in the description, and I will see you in the next one.